Okay, we are working on homework chapter 3.5. So question number 1. Of all numbers that add to 80, find the pair that has maximum product. That is, maximize the objective function q is equal xy subject to the constant of x plus y is equal 80. So the bottom line is we need to find the maximum of product. That is, and that product, maximum of product, is limited with x plus y is equal 80. Okay. So what we're gonna do, first thing we want to find from here, it's like system of equations with two variables. I'm going to find from here y, let's say, for example, it's 80 minus x. And plug this y to this one here. So in my q is gonna be maximum of product, it's gonna be x times 80 minus x. Why am I doing this? Because to find the maximum, remember we need to find the critical value and then identify its maximum or minimum. To find critical value, we need to take derivative. To take derivative, we want to end up with 1x. Otherwise, we have to use implicit derivative, which is much more complicated. So if we can take a derivative with one variable, then it's better do with one variable. At this point, so I'm substituting y with x, and I'm getting x times 80 minus x. So which is going to be 80x minus x squared. Now to find, remember we need to find the maximize. In what case this product is going to be maximum. Okay, so to find the maximum of the product, we need to get first derivative, remember from previous homework, and identify critical point and then maximum minimum. So next step is going to be find the q prime. Which is going to be 80 minus 2x, right? Okay, 80 minus 2x. Now, next step, what do we have to do? Assign to 0, right? All right, and find how much, what is critical value. So it's going to be 2x is equal 80 and x is equal 40. So this is we know our critical value. So this 40 is going to represent either maximum or minimum. So let's find out its maximum or minimum. There are two ways. Remember one way we learned, we take this critical value 40 and then find the point from negative infinity to 40 and plug to our original q, right? 80x minus x squared, this one, and see if it's positive or negative. And the same way, find some testing value between x and positive infinity, and see what's going to happen if we get q prime positive, which is plus. Let me clean this. If we get testing value plus and here testing value minus, that's mean it's going to be maximum, right? From rising to down, this will be maximum. But if we get minus and then plus, it's going to go as a minimum, right? Falling down and then moving up. we're gonna go with second method, second derivative. Instead of testing, we're gonna take second derivative. So let me take second derivative of first one, remember? All right, so q second derivative of x, it's going to be -2. What does that mean? That means, remember, if second derivative is negative, that means we are going to get concave down. This is down. Why? Let's assume, since this graph is, let's say, symmetric, right? If I represent this a graph, and for example, here slope is positive because it's rising, right? I don't understand. I'm changing color and it's using same color again. Okay, it's rising. And then here is m equal, let's say, -1, because it's falling, right? I need to use different colors so it will be well seen. This color. So this is rising, this is falling, yes? And here at this point, m is equal 0. So if you follow what's happening, positive slope, 0, and then negative slope. So slope is falling, right? Which means concave down. If it's at the concaving down, that means this critical point, which is 42, 40 in our case, it's going to be maximum. So since the x is maximum, I am going to find which y is matching to this x. So x is equal 40 is max. Now we have x plus y equal 80. So plugging x 40 plus y equal 80, and y is equal 40. So at the coordinates 40 and 40, we have maximum value. And from here, what is going to be our maximum product? So our q was x times y. So x is 40, y is 40, and our q is 4 times 4, 16, and 2 zeros attached. Okay, let's see what kind of answers we require to place there. So the value of x and y that have maximum product are x is 40, and y is also 40. Nice work. And the maximum of product is going to be 1600. Fantastic. Moving to next question, which is going to be exactly same way question, very similar. All right. So what do we have here? Maximize 8 is equal 2xy squared, where x and y are positive numbers such that x plus y squared is equal 12, and b is equal 2xy squared. So one more time, we need to maximize what will be the maximum of the product, 2xy squared. Yes, that is limited by x plus y squared equal 12. Okay. let's start working. So we need to maximize 2xy squared. That is limited with x plus y squared equal 12. Okay, let's start working. So let's find maximum using this system of equation. From the equation x plus y squared equal 12, look what's interesting. Here I have y squared, that means I can find y squared from here. So y squared, so then plugged in the b, equation of b. Y squared is equal 12 minus x, right? So plugging this y squared, plugging into here, b is equal, because we are interested to maximize 2xy squared, right? That is limited by this addition. So it's going to be 2x times 12 minus x. Remember what I said in the previous problem. We need to take derivative to find the maximum, right? First derivative, and then we assign it to 0, because at the point of maximum and minimum, derivative is equal 0. And then we can find if the point is maximum or minimum. But to take derivative, it's easier to take derivative when we have one variable. Therefore, we are substituting, converting into equation with one variable, then so we take derivative. And we have b is equal 24x minus 2x squared. From here, I'm going to take derivative, and we will have b prime is equal 24 minus 4x. Okay, so we found our first derivative. What we're going to do next? We're going to assign it to 0. And find our critical value. So 24 is equal 4x, x is equal 6. So at the point x is equal 6, we have critical value. Now the question is, this critical value is maximum or minimum? Now here will help us, instead of testing these points like I explained in previous problem, we will find the second derivative, which will be easier to work with. Second derivative, okay, it's a habit not to put of x, but we understand it's second derivative of x. First derivative also you can put of x. So it's equal -4. Yes? So at the point x is equal 6, we get -4. -4 meaning concave down. Concave down, which means it goes like this. Remember, like I explained to you, slope here is positive because it's rising. Let me take some better color. Okay, this one, because it's rising. And then here m is equal 0. So here it's becoming 0, right? It goes like that. The slope horizontal. And here is m is equal -1, going down, right? So what we get? M1, 0, -1. So 1, 0, -1. So it's going down, correct? Which means this point, this point is our maximum. Okay? All right, so let's find out how much is, y is matching to our critical value 6. So we are taking our original problem, x plus y squared. x plus y squared equal 16 or 12, I'm sorry. So from here, x is 6 plus y squared equal 12. Y squared equal 6 and y is equal plus minus square root 6. Okay, so what does that mean? Since we have maximum, because our point, critical point is maximum, that means y also, and it concave down. So our y is going to be positive, right? To be maximum. Correct? With concave down, negative cannot be maximum. Maximum is gonna be here. Therefore, we take only positive value. And so this is going to be our coordinate when x is equal 6. So 6 and square root of 6. This is our max. And to find maximum product, what was our case? B is equal to xy squared. Let me change. B is equal to xy squared. Since we have here y squared equals 6, we just put 2 times. Our x is 6 and y is also 6. 12 times 6 is 72, right? Yes. So the maximum product is 72. So this is how we optimize to know this. You can use also, let's say, if you want to find out how much maximum the volume you can pack, let's say, in the box also. All right. So we have 6 square root 6 is maximum, and it's a coordinate of maximum point. And to maximize the product, it's gonna be 72. Let's plug the answer. Maximum value of B is 6. What is this? Oh, maximum value of B. Okay. I was plugging the answer. I thought it's asking maximum, the point, critical point. Okay. All right, we got it. So it's supposed to be 72, right? It's already, it doesn't ask coordinate of maximum. All right, we are good. Moving to question number 3. So this chapter is all about optimization. Okay, how to optimize whatever is given. So a lifeguard needs to rope off a rectangular swimming area in front of Long Lake Beach using 900 yards of rope. Okay, yard, that's going to be length, obviously, of rope and float. What dimension of the rectangle will maximize the area? What is the maximum area? Okay, so let's find the dimension and maximized maximum area. Okay, so let's draw the picture. Layout, it will be easy. Okay, so let's assume here is our beach. Okay, so this is x, this side is y, obviously this side is also x because they are equal. So to maximize, we are going to maximize the area, we are going to take x times y, right? That is going to be our area, yes? Now, and this function, let me rewrite as a function of a as a function of x and y, because we are using and x and y. Okay, the function of the a of x and y is a function of two variables, as you can see. Okay, so we need to find the tool that will help us to maximize. So what do we have here? Well, let's find, we can have perimeter. Remember in previous problems, to maximize the product, our helpful tool was some addition of these variables, correct? And that helped us to maximize. So what is going to be the perimeter in our case? Since this is, we don't count, this is the beach. So we have 2x and we have y. So we need the perimeter of the our rope. It's going to be a 900 yard, right? So I'm writing down here 2x plus y is equal 900. So the previous two examples showed us to maximize the product, and we need, it's also product, y product, because we need to maximize the area, and area is a length times width. So to maximize the product, we need equation with addition or subtraction. So, and we have it, 2x plus y, this is perimeter that we will need for 900 yard. So, from here, what we're gonna do? We're gonna find y, let's say. Y is equal 900 minus 2x. Yes? And we plug this into y here. So I'm skipping xy, so it's for easiness of writing. It's going to be x times 900 minus 2x. And from here, we are going to get 900x minus 2x squared. So a prime derivative is going to be equal 900 minus 4x. We assign it to 0, right? Equal 0. So 900 equal 4x, and x is equal, so 9 divided by 4 is 2, 8, 10 divided by 4 is 2, 20 by 4 is 5, 225 yard. So next, what we're gonna do, this is our x. So now we need to find our y. How I'm going to find my y? I'm going to, where is it? 2x plus y equal 900, right? So I will find from here, y is equal 900 minus 2x. So y is equal 900 minus 2x, which means y is equal 900 minus 2 times 225. So not to wonder where from I got this, This is originally from the beginning. Remember, here it is. That's where from I took it. And here we get, so 900 minus, how much it's gonna be? 225 by 2, 450. And we're gonna get 450 yards. So from here, it's gonna be maximum area 225 times 450. So, and we are getting 101,250 yards squared. Okay, let me write down this number so I can enter the answer. So x is equal to 25. Here it is. And y is equal 450, and the area 101,250. Okay, let's go. See what we get. So let x be the length of a side of the rectangle perpendicular to the shoreline, right? The objective function of area in terms of x and y. So in my case, it was equation we put there. Equation is this one. X times 900 minus 2x. That formula it wants. So it's gonna be x time 900 minus 2x. Okay, next is going to be length of the shorter side. It's going to be 225 yard. This one is going to be 450 I got. Oh, yard. I was wondering where is yard. I'm looking yard squared. How can length be yard squared? Okay, and the answer 101,250. And this one, since it's area, it's supposed to be yard squared. Here it is. Well done. Moving to question number 4. So here we need to find the dimension. Okay, let's see how we're going to solve this one. Find the dimension of the open rectangular box of maximum volume that can be made from a sheet of cardboard 11 inches by 7 inch. So let me write down 11 by 7 inches. Okay, by cutting congruent squares from the corners and folding up the sides, then find the volume. Okay, so we need to find the sides and then the volume based on area. All right. And we need to find first dimension of the box. Let's go for it. Okay, the dimension of the box formed by folding up the sides of L by W sheet. So L is, let's mark down, L is length. W is width, right? okay? And those are measures of the sheet of cardboard. After the squares x by x are cut, squares x by x are cut from the corners. So we are going, since they are the x by x to on both sides, so it's going to be, it's cutting, it's going to be w minus 2x, and L is going to be also minus 2x, because we are cutting on both sides, right? So you can fold it. Okay, so length is going to cut by 2x on both sides, and W is going to be cut by 2x. And to find the volume of the box formed from how much we have, 11 by 7 measurements. Okay, 11 is length, minus 2x, and the width is 7 minus 2x, and we need to multiply because formula for V is equal length, height, and width, right? Okay, so x is our height is going to act, so we are multiplying also by x. So this is going to be our volume. Now, to find the dimension for which the volume is maximum, we need to take derivative, right? Because we need to find maximum. Taking derivative of v prime of x is equal x times 7 minus 2x, 11 minus 2x. Since we have all, everywhere we have multiplication, doesn't matter which one I put first, right? A times b or b times a. And we take prime. All right, so the easiest way is going to be multiply by each other first. So 7 times 11, it's going to be 77, and by all multiplication, I'm multiplying also by x, so it's going to be 77x. Next, 7 times negative 14, negative 2x, it's going to be negative 14. And this x also, it's going to be x squared. Now, negative 2x times 11, it's going to be negative 22x, and multiply by this x, it's going to be squared. And negative 2x times negative 2x, it's going to be plus 4x squared. But also we have this x, it's going to be x cubed. Okay, now we are going to take derivative. Will we have like terms? Yeah, we do, these two. Let me combine this, negative third, hold on, 14x, oh, 14x squared, I forgot here to put x squared, I put square. My apologies. This is this one. 14x, and this x will be squared. So 14, negative 14, negative 22, it's going to be negative 36x squared. I won't rewrite this expression again. I'll just use 77x minus 36x squared plus 4x cubed. So let's take derivative. Derivative of 77x is going to be 77. Derivative of negative 36x is going to be 2 times, 2 comes in front, times 36, 72x, and plus 12x squared. Okay, so we assign this to 0. Plus 12x squared equal 0. So let's see if we can, this is quadratic equation, 12x squared minus 72x and plus 77. And that is equal 0. Well, now we need to solve this quadratic equation. I'm going to go with method of discriminant, which formula is if we have ax squared plus bx plus c equals 0, so x1, 2, it's going to be equal negative b plus minus b squared minus 4ac divided by 2a. So in my equation, a is equal b equal and c equal. So a equal 12, b equal negative 72, c equal 77. Look, if I rewrite ax squared plus bx plus c, right? Okay. So let's solve it. x1, 2 is equal negative b, so negative 72 will be positive 72 plus minus 72 squared. Okay, let's do it. So 72 times 72, it's going to be 5,184 minus 4 times a, 12, and times c, 77. So it's going to be 4 times 12 is 48. 48 times 77 is 3,000, hold on, times 12. This is going to be 72 plus minus square root 5,184 minus 3,696 over 24. So let's see how much we get. 5,184 minus 3,696 equal 1,400. 1 second. 72 plus minus square root of 1,488 divided by 24. Now let me see how much it's going to be square root of 1,488. I'm assuming it's going to be approximate value with decimal because I don't think any precise number will come out. Square root this one, and I get 38.57. So I get 72 plus minus 38.50. Well, I could put 58. I would put 58 because I have 38. My number is 38.5746. If you look, see, because the 6 will round till 5, and accordingly that will round to 8. That would be right way to round it like that. Okay, and we divide by 24. Okay, so what do we get? Obviously, if we get negative number, we are going to cancel, but we don't get negative number. Yeah, 72 is bigger than 38. All right, so plus 72, and x1 is equal 72 plus 38.58 and divided by 24. Now we separate this plus minus, okay, at the end. And x2 is equal 72 minus 38.58 over 24. Let's go for it. So 72 plus 38.58 and divided by 24, it's gonna be 4.61. And next one, 72 minus 38.58 and divided by 24, it's gonna be equal 1.39. Okay, we got this far. So from here down, I thought I'm recording, so I continued explanation and entered the answer, and it got correct. And I didn't realize that realistically it wasn't recording. So therefore, instead of cleaning and solving over again, so I decided just go over one more time and explain what's the rest of it about. First of all, see these two answers that we got. This 4.61, it's not gonna satisfy to solution because look here, we have 11 minus 2x and 7 minus 2x, right? In the beginning, it's length and width. Where is it? Here it is also. 11 minus 2x times 7 minus 2x. Because we cut the x by x, so we reduce in width and length by 2x. And because we reduce by 2x, we see here that if we plug 4.61 in 7 minus 2x, 2 times 4.61, we are getting negative number because 2 times 4 is 8. So 7 minus 8 is negative number. Therefore, 4.61 cannot participate as an answer. And we end up only with one answer, 1.39. So once we have x is 1.39, we are going to get how much will be 11 minus 2x. Here it is. I solved it. 11 minus 2 times 1.39, and we get 8.22. And also we need to get 7 minus 2x for width. Here it is, w equals 7 minus 2x, 7 times 7 minus twice 1.39, and we got 4.22. So, and here I wrote down 1.39, 4.22, 8.22. So let me show you how you're gonna enter this answer. I don't have anymore the same numbers to enter because it's generating different answer, but I'll open here completed version of it just to show. Look here, this 3.31, 9.36, and so on. All these numbers entered in one window. See that? So don't get confused. Put one window and expect the other one will open. So everything through comma you put in one window, and here you choose inches because measurement is with inches. In the case of maximum volume, you are going to enter, of course, this multiplication, 48.22, because volume is equal x times, which is 139, times 11 minus 2x, which is 4.22, and then times 7 minus, 11 minus 2x, 8.22, and 7 minus 2x, 4.22, and we get 48.22 inch cube. Okay? So, and said that, I am moving to question 5. Let me take this off. So, question number 5. What do we have here? Drum-tight container is designing an open-top square-based, pay attention, it's square-based rectangle box that will have a volume of 62.5 inch cubed. Volume we measure in cubic, right? Inch cubed. What dimension will minimize surface area? Now we need to know what dimension will minimize surface area and what is the minimum of surface area. So which dimension will satisfy minimum of surface area, and what is the surface area? Okay, let's start working on it. So we are given volume of 62.5 inch cube. Okay, so first thing, what we are going to do, because we have square, then the both sides are going to be equal, right? Let me see if I can make it square. Yeah. So if one side I put S, why I don't put L and W? Because we have square, they are equal to each other. Yes? So volume we know. Volume is equal length, width, and height. Since our S is equal length, S is equal width, they are all equal to each other because it's the square, then our volume is gonna be equal S times S, which means S squared times H. So our volume 62.5, this is equal S squared times H. Okay, now we need surface area also, right? For surface area, we are going to have S squared, so it would be L times W, the area, right? But because we have S and equal L and W equal S, so we put S squared instead of L times W, right? S squared plus 4SH. So side times height. Okay, so in this case, so what am I going to do? To minimize, I have to take, because it's asking which dimension will satisfy minimization of the area of surface. So we take our area of surface and we have to take a prime, right? Derivative. Now, in this case, a prime, we have, since we have two variables, S and H, just like in previous cases, I'm going to get rid of H, meaning express H through S. How I'm going to do? Through this volume, from this the equation. So I'm going to find H, and I will find H divided by S squared, right? So, and the result is going to be 62.5 dividing by S squared is equal H. So from here, 62.5 dividing by S squared, I am plugging into this area, formula into area. Let me plug in first. So A is equal S squared plus 4S, and instead of H, I am plugging times 62.5 divided by S squared. Now this squared is gone with this S, right? And we are having S squared plus, 62.5 times 4. I'm getting 250 over S. Let me move for a second this question so it won't get into inactive mode. Okay. So now we're going to take a prime. To take a prime, I have to take derivative of S squared and derivative of 250 over S. How I'm going to do? So A prime is equal, derivative of S squared is 2S. Now this one, 250 over S. This is 5. Let me do drafting 250 over S. This is, I'm writing down 250 S to power negative 1, right? 1 over S is equal S to power negative 1. So it's going to be equal 250 times negative 1 come in front, S and negative 1 minus 1. Remember our formula? X to power n is equal n times x to power n minus 1. Since our degree is negative 1, so negative 1 comes in front. And negative 1 minus negative 1, we are getting 250. Negative comes in front here. And s to power negative 2. Now, s to power negative 2, it's going to be 250 divided by s to power positive 2. Because it's going to go backwards, vice versa. The x to power negative n is equal 1 over x to power positive n. Okay? All right, so it's going to be, in our case, it's going to be minus. That's why plus convert into minus. Hold on. Okay, let me get out of it. Okay, so it's going to be 2s. This is s. 2s minus 250 over s squared. Okay, now once we have it, we are going to take a prime. We are going to take a derivative equals 0, right? To get the critical value, which is going to be the maximum or minimum. So 2s minus 250 divided by s squared equals 0. How I'm going to solve? It's bringing to common denominator. Common denominator s squared, which means s squared here times x squared here. And since I have s squared, I am throwing out of window this denominator, and I will have 2s cubed minus 250 equal 0. Okay? So 250 equals 0. This is going to be equal 2s cubed equal 250. From here, s cubed is equal 125. And s is going to be equal 5. If you take cubic radical from 125, you are going to get s that is equal 5. Okay, so once we have it, what am I going to do next? I need to find a second derivative because we have this critical value. Now we don't know if this is going to give us maximum or minimum. To find out if this is maximum or minimum, then a measurement, then we are going to take second derivative, right? So first derivative is a prime is equal to s minus 250 by s squared. Now if you take second derivative, it's going to be equal to, and 250, it's going to be, okay, minus 250, and derivative of 1 over s squared. I am going to represent as s to power negative 2 prime, and this is equal negative 2 s to power negative 3, negative 2 minus 1, negative 3. So, and then negative exponent represent as a positive. Yes? And we are getting times 2 over s cube. And this negative with this negative, it's going to give us positive, right? So this is becoming positive. So from here, my s is 5. I plug this 5 into this s cubed, right? And let's see how much I will get. The double prime second derivative. So that's going to be 2 plus 500 divided 5 cube is 125. And we are getting equal 500 divided, I'm multiplying, 500 divided by 125. It's going to be, what's happening? 500, I'm getting 2000 divided by 125 equal 4. Okay, and 4 plus 2 is 6. It's positive, greater than 0. So that's mean concave up. Right? Why we call this concave up? Because look, here we have -1, let's say, slope going down. Here we have slope is equal 0, m is equal 0. Let me rewrite clear. M is equal -1. And here we have rising, right? M is equal +1. So look, -1, 0, +1, which means it's increasing, correct? Concaving up. Therefore, this point is minimum. So s is equal 5 is providing our minimum. So let's find our h. So all we have to do now, since we know s is at the side of minimum area. So where was our h? H was here, 62.5 divided by s squared. Yes? Let me write down. H is equal 62.5, because once we found s, we need to find s. Why? Because we need to plug into this formula, right? To get the minimum area. To minimum size, we are getting minimum area. There. So H is equal 62.5 divided by, is it 62.5 in my case? Yes. 1 second, let me check here something. Yeah, 62.5, that's right. So I'm going to divide by s squared, which is 5 squared. So 62.5 divided by 25. Divided by 25, and we are getting 2.5. And from here, I'm going to get the area of surface. Area of surface is equal s squared, which is 5 squared, plus 4 times 5, and times 2.5. Yes, this is multiplication, this is 2.5. And we are getting 25 plus 4 times 5 is 20, and 20 times 2.5, we are getting 50, and it's going to be 75. So 75 inch squared, because that's an area. So what do we have practically? Let's put the answers. At the side is going to be box dimension is going to be 5 in width, and then h is going to be 2.5, and area is going to be 75. Let's go for it. Let's place the answer. What we need. The length of one side, yes, it was 5, right? And this is inch. The height was 2.5. 2.5. And here is inch. Okay, let's check it. Fantastic. And the minimum surface, we set 75, right? $75, and it's gonna be inch squared because area. Volume is measured in inch cubed, right? Fantastic.